moved from susceptible to infected. They've received a message. Now, the flip side of that is a question of where that message comes from, and we're going to see that right now. Specifically, you'll see within this state chart a self-transition, a transition from that state to itself. In other words, a transition that fires but doesn't lead the agent to leave the state. They stay in the same state, but something happens when that transition occurs. So here we have a transition which occurs from the infectious state into the infectious state, and it occurs with a certain rate. So implicit in this is conditional on you being in the infectious state. This thing would never fire if you're not in that state. But once you're in that state, it's going to fire at a Poisson arrival, a certain chance per unit time that it will go off, and that likelihood density, that chance per unit time, that hazard is given by this rate here. This is an expression that specifies the rate. Now, what I want to draw your attention to, more specifically though, is the action associated with it. So when this transition occurs, when an individual who's in the infectious state has this contact transition that occurs, they send a message. That's what the send is. It's a request that says, hey, send a message called infection to a random neighbor of mine. Okay? Where that random neighbor is defined to mean a neighbor in space. We would say something a little bit different, random connection, something along those lines, or neighbor in a network. So this means a randomly selected neighbor. Now, there's some work that goes on to pick that neighbor, but it's with uniform probability. You'd rather be the neighbor. This could be done manually quite easily, but AnyLogic builds it in just because it's so common. It's going to be one of your immediate neighbors in the physical space in which you're located. So in other words, it's only going to go to someone within one hop from you in this grid. So if you're in a grid like this, and you're located, the index person, as it were, is located, say, in this cell, it's only going to send it to an immediate neighbor, someone who's one hop away in the grid. And it turns out that the neighborhood definition, so within the environment in which the space is defined, it's going to specify, is it one of these 4, or is it one of these 8 that would include northeast, southwest, southeast, and northwest. So it's going to sort of what's considered a neighbor, random neighbor, what's considered a neighbor depends on the environment definition. But in both cases, it's one hop away. The question is, do you count the diagonals as being 1 hop or 2 hops away? Okay.